Here we have a list of equations to solve. 4x. I'll write a 2 next. Let's just start. 4x minus 3y equals -1. 3y, 3 could be 3x. I think everybody copied that down as an x. Plus 4y equals -7. Okay, now people are following the scheme that I've recommended. We call this equation 1. We call this equation 2. Now I'm going to do something just a little different. I'm going to put brackets, square brackets around my system. Okay? Just to indicate here's the system. Okay? Instead of writing a line here, I'm just going to write square brackets. And I'm going to number the rows of the system. This is a row, this is a row. I'm going to number them 1 and 2. Okay, now I'm going to do 3 times row 1 and -4 times row 2. Okay, well, we multiply 3 by each of these numbers. 3 times 4 is 12, so we have 12x. 3 times -3 is -9, so we have -9y. 3 times -1 is -3. Be careful that you remember to multiply both sides. You don't multiply just the variable that you're picking on, or the term that you're picking on. You don't multiply just the left-hand side, you multiply both the left and the right-hand side. Those are just common errors. You want to be sure you're not making, okay? I didn't say anybody make those errors, but just to caution everybody, including distance students. Okay, and then when I multiply the second one by -4, I do -4 times 3, I get -12x. And you see what's going to happen because you know I'm going to add these rows. My 12x and -12x are going to give me 0. That's going to eliminate x from the equation. Okay, so I do 12x and -12x. And then I have -16y because -4 times 4 is -16. And -4 times -7 is 28. Okay. Now what I do, I'm going to write the system down. And this is a little different. I'm going to write equation 1. Now, in the past, we haven't been writing this equation because we just add these two and solve for y and back substitute. So when I put the brackets, I'm always going to have 2 rows. I'm always going to have 2 equations. We have 12x minus 9y equals -3. Now, second row, I'm going to do equation 1, first line 1 plus line 2. Line 1 here, line 2 here. Okay. And when I add 12x and -12x, I'm going to get 0. I'll write out the 0x. And I'm going to have -9y and -16y. That's going to add up to -25y. People are adding their rows, I think, correctly and multiplying correctly. So it's a good start. Okay. And then I'm going to have -3 and 28, which is 25. Okay. Now what I'm going to do, I'm going to keep row 1 there. And that's about what I did before that. One wasn't counterproductive. Okay. I'm going to do row 2 divided by -25. This gives me 12x minus 9y equals -3, and 0x plus y, because what is -25y divided by -25 is going to give me 1, so that just gives me 1y. And, you know, I'm going to be a little more explicit. I'm going to write the coefficient down. I'm going to write 1y. And -25, well, 25 divided by -25 is -1. Okay. At this stage, we get y equals 1. And I could say a little more about that. I don't think I maybe want to. Row 2 now tells us that y equals -1. Okay, so let's see again, row 2. Zero x plus 1y equals -1. In other words, 0x is 0, so we don't even need to write that. 1y is what? Y equals -1. Now we substitute y equals -1 into equation 1. And solve for x. Okay, see if you can do that. Okay, now apparently some students don't understand what it means to substitute y equals -1. Okay, now maybe there's a confusion about where equation 1 is, but that's it. It's the last equation labeled 1. Okay, so let's talk about what it means to substitute. Should do this in a different color. Okay, so equation 1, maybe I'll use a different color. No. Supposed to make chalk out of soft stuff. If somebody got into a limestone mine or something. Okay. Equation 1. Last equation 1 we saw is here. Now, we could have used any of these equations, equation 1, okay? But we'll choose to use the last one. Okay, it's 12x minus 9y equals -3. Now substitute y equals 1. We get 12x minus 9 times 1. Okay, so here's y. We change y to 1. That's what it means. Substitute y equals 1. Okay. Now, can we solve this equation? And the Lighthouse have us in focus again. So we have this. And what do? We multiply the -9 by the -1. Now you notice that this equation's been rewritten because when I wrote substitute y equals 1, I should have substituted y equals -1. I had a faint negative there. I wasn't thinking. I just took what I saw at the corner of my eye and wrote it down, and it wasn't right. And it was going to lead to a wrong solution. Okay, now, not everybody multiplied these two numbers, even when there was a 1 in there, okay? Some did, some didn't. This is automatic. You got two numbers multiplied together, you multiply them. If you have an equation, you simplify it. Okay, so what do we get? We get 12x plus 9 equals -3. And then we add, in this case, it'd be -9 to both sides. Now, people did multiply this out, did subtract 9 from this side, but then they would have added 3 to this side. Okay, you got to do the same thing on both sides. So we write this as 12x plus 9 minus 9 equals -3 minus 9, which gives us then 12x equals -12. And we get a solution. We divide both sides by 12, and we get x equals -1. Now we have a solution to the entire system. We check the solution. So can you now substitute x equals -1 and y equals -1 into the first equation here, and then substitute it into the second equation and see if you get identities. Okay, so what we need to do is plug in -1 for x, -1 for y into the first equation, see if it gives us an identity. And then into the second equation and see if it gives us an identity. Okay, well, into the first equation. Okay, so what? First off, solution. X equals -1, y equals -1. Now we check. I check. Substitute x equals -1, y equals -1. In each the original equations. Okay. Meaning we start with the first equation and substitute -1 for x, -1 for y, and we do the arithmetic and see if both sides come out the same. Both sides come out the same, then we have an identity. And then we do the same thing for the second equation. So continue to work on that. If you haven't done that, do it now. Be sure you substitute into each of the equations. I said that earlier, but apparently not everybody heard everything I said, and that happens. I should have written it out, okay? But there we have it. And this has to be an automatic step. We have to know how to check. So this is what it comes down to. Take our solution. Once we get a value of x and y, put it into each of the original equations and see if we get equality on both sides. Okay, now still not always seeing what we mean by substitute x equals -1 and y equals -1. Okay, so you have to understand what that means. Let's be very meticulous in doing this. Now, some people this time around got it and got it rather quickly, and some people didn't get the substitution right yet. Okay, so first equation is okay. Substitute x equals -1, y equals -1. What do we get? We get 4 times x minus 3 times y equals -1. I've left x and y values empty for the moment, but now we're just going to throw in x equals -1 and y equals -1. So now we have 4 times -1 minus 3 times -1 equals -1. 4 times -1 is -4. 3 times -1 is +3 equals -1. We still got to calculate this. Have to use a calculator to calculate this. So be it, although you should be able to visualize this on the number line. We get -1 equals -1. Put a circle around that and a check mark because -1 was a solution to the first equation. Now before, when I did this, my equation 1 was the last equation what I had, right? Here it's the first, and I want to write down. We use the first one. We use the original equation, in other words, because we want to make sure the original equations are correct, are satisfied. Okay? If we've done all the steps right, then every one of these systems ought to be satisfied because they're all equivalent. Okay, well, now check equation 2. Equation 2 is 3x plus 4y equals -7. Well, we substitute. Let's be very explicit. And we get 3 times whatever x is plus 4 times whatever y is equals -7. And x is -1 again. And y is -1. And we get 3 times -1 is -3. 4 times -1 is -4. It's plus a -4, which is just -4, equals -7. And we add this up and we get -7 equals -7. Throw the monstrous negative sign there. But okay. Now we're sure our solution works. All right. Now we also can relate this back to what happens if we graph these two functions. Okay. So just quickly. Since I use small numbers, you know, the x-intercept is going to be -1/4. The y-intercept is going to be +1/3. So here we have a straight line that looks something like this. to the second equation, the x-intercept is going to be -7/3. Okay. Now let's see, -7/3 might be out about here. It's actually a little further out. But we'll say that's it. Okay. And we're not going to get a great answer. I'm just illustrating the process. And the y-intercept is -7/4. We're going to have a line that does this sort of thing. And this point where the two lines cross is going to be -1, -1. And that's plausible, given that I didn't leave myself room to put that -7/3 in there. If it's done neatly and carefully, going to get a graph. It looks much like this. With a crossing point at 1, -1. We want to review that. Okay. So let's try this system. I'm going to do exactly this analogous thing. And as I said, write out every word, every step. Of course, your numbers are going to be different, but all the other words are going to be the same. If you write out the words, then you're going to be more likely to understand it, and you need to practice. You need to go back to the solutions of systems of 2 equations in open math and solve those systems using this scheme. Okay? Because, well, let's just leave it at that. Okay, so here we have it. Okay, so let's solve this system. Imitating, let's see here. I'm going to write the system in brackets. And labeling up the lines 1 and 2, the rows 1 and 2. I'm going to call these rows, not lines. So what I'm going to do is I'm going to do 4 times equation 1 and -5 times equation 2. Because 4 times 5x gives me 20x, and -5 times 4x gives me -20x. I think everybody got to that point. So I'm going to get 20x minus 35y, not 35. I have a 5 in my head. You got to be careful. 28y, sorry, equals 48. I think everybody pretty much got that. Some people were kind of stuck on the second equation. Some people just went on and, got down to a step where they could solve for y. Okay, well, anyhow. -5 times equation 2 is -20x. -5 times 9y is -45y. And -5 times -5 is 25. So now what do? I write down equation 1. I write down equation 1 plus equation 2. Because what I'm going to do is I'm going to add these 2 equations. The result's going to go in the second row. The first equation will still occupy the first row. So I've got 20x minus 28y equals 48. Then I've got 20x minus 20x is 0x. Negative 28 minus 45. Now let's be sure here. Yeah, negative 28 minus 45. I think somebody had a arithmetic error in putting these together, missed a minus sign or something. It had the right stuff. You got to be careful. And that's going to give me 73y negative. And then 48 and 25 is 73. Okay. So now what do we do? Now, what did we do before? We got down to this system here. And then in the next step, we see that we have no x there, so I wouldn't even have to write this. We have the equation negative 25y equals 25. Now, I included the 0x there in anticipation of how we're going to set this up with matrices. We'll have to get to that next time. Okay, so there's a reason I'm including the 0x. So we want to include it. We want to get used to it and used to what it means. What it means is there's really kind of nothing here, but we're going to represent that by 0. Okay, now, imitating what we did. What did we do in the next step? We divided the second equation, previous second equation, by negative 25. Why would we divide by negative 25? Because that's going to solve for y. Okay. If we have negative 25y equals 25, we want to solve for y, we divide both sides by negative 25. So we're going to divide this equation by negative 25. Now, over here, it's not negative 25, it's negative 73, right? We want to solve this equation, which is basically just negative 73y equals 73. We have to divide by negative 73. So we do equation 2 divided by negative 73. We're going to leave equation 1 alone. So we've got 20x minus 28y equals 48. And then we have 0x. We divide negative 73y by negative 73, and we get 1y. And we divide 73 by negative 73, and we get negative 1. Now, that's kind of worth writing out. We have taking this equation out of the matrix, out of the brackets. We don't have to write the 0x. We get negative 73y equals 73. And we divide and we get 73 divided by negative 73. And that implies that y equals negative 1, because negative 73y over negative 73 is just y. And negative 73, and it's not negative, yeah, it's equals 73. Okay. And 73 divided by negative 73 is negative 1. So this tells us, writing out every word. 2 says y equals negative 1. Well, what do we do next? Substitute negative 1 into the first equation. I'm not going to do it quite as explicitly as I did it before, partly because we only got 3 minutes left, and partly because go by this. Okay. Uh, Now, actually, I'm going to do what I said. Okay. I'll just do it quickly. 2 says 0x plus 1y equals -1. So y equals -1. Now we substitute y equals -1 into 1 and solve for x. I want you, even though I'm, we're pressed for time, I'm still going to do what I said. I'm writing out every word. Write out every word. It's going to sink in better. Okay, so, and I'm not going to use all the colors. One is our equation 1 right now is referring to the most recent equation is 20x minus 28y equals 48. So we get 20x minus 28 times -1 equals 48. This gives us 20x plus 28 equals 48. We subtract 28 from both sides. And we get 20x equals 20. We do 20x divided by 20 equals 20 divided by 20. And we get x equals 1. So we'll circle x equals 1. Well, I didn't circle it before, but I'll take the liberty. Okay. Now what? We check. Okay, so now we're over to the substitute x equals -1. Well, substitute this into each the original equations. I've got a double underline on original. Write that out. I'm recommending that you practice this so you can do this efficiently on an exam. Okay? Or in your pre-calculus class, you're still in that class. Okay? Some distance students are. Substitute this into the original equation. So the original first equation was 5x minus 7y equals 12. We substitute 1 for x. 5 times 1 is 5. -7 times -1 plus 7 equals 12. We add that up and we get 12 equals 12. Circle that, put a check mark. We write the second equation. Now I am leaving out a few of the words I used over here. You notice I didn't write substitute x equals 1, y equals 1. I should have indicated this is equation 1, indicate this is equation 2, and equation 2 is 4x plus 9y equals -5. we get 4 times 1 plus 9 times -1 equals -5. That's 4 minus 9 equals -5. Gives us -5 equals -5. That checks, and now we know we have the correct solution. Now, also be, not a bad idea to sketch the graph and see if that works. But you might not have the time, so at least get this process down. And the one thing I didn't write out is what I've got in purple here. Substitute x equals 1, y equals -1. Yeah, and substitute here. So you would want to write that in just as I wrote it. I recommend you do several problems like this, because we're going to develop this into something else next time.